In this presentation, I will examine number 1, the general overview of learning curve. The general overview of learning curve. Number 2, I will as well as examine the conditions under which learning curve theory operates. The condition under which learning curve theory operates. Number 3, I will examine the methods of solving learning curve. Methods of solving learning curve. Number 4, I will also examine how to calculate the learning curve rate. How to calculate the learning curve rate where this is not provided in the question. Number 5, I will solve 4 different questions as work examples. Please don't forget to click on the subscribe button in red if you have not subscribed in the past. Also, turn on your notification bell icon so that you'll be able to receive a notification message each time I drop a new video. If you are a returning subscriber, I say thank you and God bless you. Learning curve theory or learning curve theory operates on the assumption that as a worker becomes familiar with a new job, his experience increases, resulting in a decline in time required by him to perform the job. Learning curve theory operates on the assumptions that as a worker becomes familiar with a new job, his experience increases, resulting in a decline in time required by him to perform the job. Learning curve theory states that learning curve theory states that whenever a repetitive job is performed, whenever a repetitive job is performed, the average time spent in producing a unit force by a specific percentage whenever the activity level is doubled. Whenever the activity level is doubled. Learning curve theory states that whenever a repetitive job is performed, that is when you continue repeating the same job, the same task, when you are repeating it regularly, the average time spent in producing a unit, the time you spend in producing a unit falls by a specific percentage whenever the activity level is doubled. I want you to know that this learning curve theory was developed in 1925 at the Wright-Patterson Air Force Base in Ohio University, United States. I want you to take note of that. The theory states that when you keep on performing the same task, when you perform the same job, you acquire experience and you become familiar with the job. The time, that means you'll be able to perform that job faster than before. the time you spend in performing that task will fall by a percentage when you double the level of activity. That is the statement of the theory. So this can simply be explained as a worker carries out a repetitive task. As the worker carries out a repetitive task, his dexterity will improve. His dexterity will improve. 2. The initial bottleneck associated with the task will be overcome gradually. That is, whenever a repetitive task is performed, number 1, the dexterity of that worker will improve. Number 2, the initial bottleneck associated with the task will be overcome gradually. And number 3, he becomes familiar with the problem. He becomes familiar with the problem areas and finds an appropriate solution to take care of such problems. So, as a result of all this, a lot of time is saved and the time used in the task reduces. So that is learning curve. Learning curve theory states that whenever a repetitive job is performed, the average time spent in producing a unit falls by a specific percentage whenever the activity level is doubled. Conditions under which learning curve theory operates. Conditions under which learning curve theory operates. Conditions under which learning curve theory operates. Learning curve theory operates under the following conditions. The theory operates under the following conditions. Number 1, the task must be repetitive in nature. Number 1, the task must be repetitive in nature. That is, it must be a repeated task. It must be a repeated task. Number 2, the task must be labor intensive. It must be labor intensive, where most of that job will be carried out manually with the use of manpower. That means the speed of that labor is not being dictated by the machines. Number 3, management must be able to motivate workers. There must be motivation. Management must be able to motivate workers. The workers must be motivated. The workers must be motivated. There should be little or no labor turnover. There should be little or no labor turnover. No labor turnover. Number 5, the task must be continuous. The task must be continuous. These are the conditions under which learning curve theory operates. Number 1 condition, the task must be repetitive in nature. Number 2, it must be labor intensive. Number 3, the management must be able to motivate workers. Number 4, there should be little or no labor turnover. And the last one, which is number 5, the task must be continuous. It must be continuous. Methods of solving learning curve. Methods of solving learning curve. Methods of solving learning curve. There are 2 methods of solving learning curve problem. Methods of solving learning curve. There are 2 methods of solving learning curve problem. Number 1, we have the tabular method or the tabular approach. Tabular method or the tabular approach. Tabular method or tabular approach. That is the first method. That is, under this method, you are going to use a table. You are going to use a table, and this table will provide answer to the following columns. It will provide answer to the following columns. Number 1, the first column, you might have the quantity. The second column will be cumulative quantity. Cumulative quantities. The third column will be hours, if possible, or cumulative hours. Cumulative hours. Or you may have hours first before your cumulative hours. Then you might have the incremental hours. But these are the major columns. Then cumulative hours. Then we can also have average cumulative hours. Average cumulative hours, which will be obtained by dividing the cumulative hours by the cumulative quantity. To obtain the average cumulative hours, you divide the cumulative hours by the cumulative quantity. Cumulative hours divided by the cumulative quantity will give us the average cumulative hours. Bear that in mind. That is the tabular approach. The second method is algebraic approach. Algebraic approach from the word algebra. This approach, problems under this method is solved using this formula: y equal to ax raised to power b. Y equals to ax raised to power b. This tabular approach I've explained has some limitation. It cannot be used to solve all problems. It cannot be used to solve problems where the cumulative output or cumulative quantity cannot be obtained through continuous doubling. That is, the output required where that output cannot be obtained through continuous doubling, you cannot use the tabular approach. That means only the algebraic method can be used. Now let's define the variables in this formula, algebraic approach, where your x is the cumulative number of units. Cumulative number of units, or the total output. X is the cumulative number of units, or the total output, cumulative number of units divided by the number of units in the first batch over number of units in the first batch cumulative output or cumulative number of units divided by number of units in the first batch. Then your y, this y equals to cumulative average time per unit to produce x unit. cumulative, or let me say average time per unit, average time per unit to produce the cumulative output. Average time per unit to produce the cumulative or the total output. Number the A is time required to produce the first unit. Time required to produce the first unit of output. Time required to produce the first unit of output. And B in this formula, B is the index of learning. B is the index of learning, and the index of learning equals to logarithm of learning rate, logarithm of learning rate over log 2 over log 2. The index of learning, B is the index of learning, and that is logarithm of learning rate over log 2. That is the algebraic approach. So I want to examine how to calculate the learning rate, estimating the learning rate. Estimating the learning rate. Estimating the learning rate. There are two methods of estimating the learning rate where this is not provided in the question. The number one method is the algebraic method. Algebraic method. Algebraic method, and this method is solved using this formula. AR raised to power n equals to average cumulative time or cumulative average time per unit. Cumulative average time per unit. AR raised to power n equals to cumulative average time per unit, where A is the average time of producing the first unit. A is the average time of producing the first unit. Average time of producing the first unit. A is the average time of producing the first unit. R is the learning rate. Learning rate, that is R. N is the number of times the activity was doubled to obtain the cumulative output. Number of time the activity is doubled. Number of time the activity is doubled to obtain the cumulative output. So that is with the use of algebraic method. I've told you that algebraic method, we use this formula AR raised to power n. You equate the AR raised to power n to the cumulative average time per unit, where the A in the formula represents the average time of producing the first unit, and R is the learning rate, and the N is the number of time the activity is doubled to obtain the cumulative output. And the second method which may be used in estimating the learning rate is the tabular approach. The tabular approach. So these two methods will be used to solve each of the questions I'm going to solve in this presentation. Example 1. Average unit times for product X have been tabulated as follows. Average unit times for product X have been tabulated as follows. You have the unit number and you have the cumulative average time. You have 1, 2, 4, 8. If the first output is 1, when you double 1, that is when you multiply 1 by 2, it will give you 2. When you double 2, it will give you 4. When you double 4, it will give you 8. Then the average time is 20 minutes, 17.2 minutes, 14.792 minutes, and 12.72 minutes required. What is the learning curve rate? What is the learning curve rate? That is the question. We are going to solve the question using both the tabular approach and the algebraic approach. I want to start with the use of algebraic approach or algebraic method. So, solution. Using the algebraic method, I've told you that the formula is a raised to power n, which is equals to, I've told you that a raised to power n is equal to cumulative average time per unit. Cumulative average time per unit. The cumulative average time per unit is 12.72. 12.72. The average time for the total output, which is 8 units. The total cumulative output is 8. And the time per unit, you have been told cumulative. At the top of the question, you have been told that this is cumulative average time. Cumulative average time. Average time for a unit. That is the meaning of average for just one unit. So since it is cumulative average time, that means you have been given the cumulative average time to be 12.72. So that means this one is 12.72. Our A is, I've told you that A is the average time of producing the first batch. The first batch or the first unit. The time for producing the first unit is 20 minutes. That means our A is 20. So we have 20, which is A. R, I've told you that R is the learning rate. And I've equally told you that N is the number of time the activity is doubled to obtain the cumulative output. So the cumulative output is 8. How many times will this activity be doubled to obtain 8? When you double it, when you double 1, if the first output is 1, if you double 1, that is if you multiply 1 by 2, that will give you 2. That is first time it was doubled. The first time of doubling 1, if you double 1, you have 2. That is first time. That is number 1. If you double 2, you have 4. That is number 2. That is the second time. Number 2. If you double 4, you have 8. That is number 3. I repeat, if you double 1, you have 2. That is the first time. If you double 2, you have 4. That is the second time. If you double 4, you have 8. That is the third time. That means to obtain this cumulative output, this activity has to be doubled 3 times. The activity has to be doubled 3 times. That means the number of times the activity will be doubled to obtain the cumulative output is 3 times. That means our R is 3. If R is 3, then solve for R. You now divide both sides by 20. That means R raised to power 3 equal to 12.72 divided by 20. And if you divide that, then you'll be having R raised to power 3 equal to, if you divide 12.72 by 20, then you'll be having 0.728125. 8125. You want to solve for R. If you divide 12.72 by 20, then you have 0.728125. To solve for R, you find the cube root of 0.728125. And if you find the cube root, it will give you 0.9 or 90%. If you multiply 0.9 by 10, it will give you 90%. Therefore, the cube root of 0.728125 is 0.9. If you multiply 0.9 by 10, by 100, it will give you 90%. So that is 90%. That is with the use of the tabular approach. The use of algebraic approach. Then if you want to use the tabular approach, that means you will need to find the percentage decrease in this cumulative average time. The cumulative average time has been given. Then you find the percentage decrease in the cumulative average time. How do you calculate the percentage decrease in the cumulative average time? So the percentage decrease in cumulative average time. So let me just complete that in this table. Percentage decrease in cumulative average time. Remember, our cumulative average time is this column. Let's find the percentage decrease. This remains 20. This is nil. To find the decrease now, it was 20 before. It has now reduced to 17.2. So that means you have 20 minus 17.2. This minus this over 20 over the first one, then multiply by 100 over 1. So 20 minus 17.2, that gives us 2.8. If you now divide 2.8 by 20 again, divided by 20, then you have 0.14. 0.14. Sorry, there is a mistake in this figure. 12.72 divided by 20, that gives us 0.636. When you divide it by 20, it will give you 0.636. When you now find the cube root of 0.636, the cube root of 0.636. If you have used your calculator, you'll be able to detect that error at first. The cube root of 0.636 is 0.85997. Therefore, R is approximately equals to, if you multiply this by 100, it will be 85.997, so which is approximately equal to 86%. So the learning rate is 86%. Now, using the tabular approach, our learning rate, I've told you that when you subtract 20 minus 17.2, that gives us 2.8. 2.8 divided by 20, we have 0.14 times 100. Then you have 14%. 14%, that is the percentage decrease. Then the second one, you have 17.2 percentage decrease in between this and this. 17.2 minus 14.792 over the initial, which is 17.2 times 100 over 1. So if you have 17.2 minus 14.792, then you have 2.408. 2.408 divided by 17.2. Then you have 0.14 times 100. That will also give you 14%. Then for this, you have 14.792 minus 12.72 over initial, which is 14.792 times 100. Then you have 14.792 minus 12.72. Then you have 2.072 divided by 14.792. Then you have 0.14 times 100. Then you equally have 14%. So since we have this, our learning rate now, you now subtract 14%, percentage decrease, 14%, you subtract it from 100. 100 minus 14, it will give us 86. Therefore, our learning rate is 86%. So learning rate equals to 100 minus 14, which is 86%. You can see that the result obtained under both the tabular approach and the algebraic approach are the same. That is the first example. Then we want to consider another work example, example 2. This question is also obtained from Kaplan, ACCA Performance Management. The first question is equally obtained from Kaplan, ACCA Performance Management, F5 study test. SCWPSC has budgeted for a learning rate of 95% on the production of its new product, Q, which is still at the development stage. The budgeted learning rate was 95% and that product was still at the development stage. Actual results were as follows. We have the time to make the first unit of Q, which is 40 minutes. Time to make the first 8 units is 233 minutes required. Calculate the learning rate. Assuming a steady state has not been reached. The learning rate solution. So now using algebraic approach, we said the formula is A raised to power n, where A is the time used in producing the unit in the first batch. So if you go back to the question, you were told that the time to make the first unit is 40 minutes. So that means our A is 40 minutes. R is the learning rate, and that is what we are required. R is the learning rate. Then we are left with N. How many times would the activity be doubled to obtain the cumulative output? You know, the cumulative time to make the first 8 units. The cumulative output is 8 units. How many units were in the first batch? Time to make the first unit. The first unit will be 1. If you double 1, that is, if you multiply 1 by 2, you have 2. That is the first time. The second time, times 2 again, you have 4. 4 times 2 again, we have 8. I repeat, the first unit is 1. If you multiply by 2, if you double the 1 by multiplying it by 2, we have 1 times 2, which is 2. That is the first time. The second time, if you multiply by 2, by doubling it again, we have 2 times 2, which is 4. The third time again, multiply that 4 by 2 again. 4 times 2, 8. Meaning that you are going to double it 3 times before you can have this 8. The number of times it will be doubled to have the 8 is 3 times. So that means our n equals to 3 as well. And I've told you that this expression is equals to the cumulative average time per unit. Cumulative average time per unit. We know the cumulative output took 233 minutes. To get the average time per unit now will be 233 minutes divided by the number of units divided by the cumulative output, which is 8. That means 233 divided by 8. Then we have 29.125. This is 233 divided by 8 is 29.125. So now back to the formula. AR raised to power n equals to 29.125. 29.125. Where A is 40. So that means we have 40 R raised to power n. N is 3. So we have 40 R raised to power 3 equals to 29.125. So you divide both sides by 40. We have R raised to power 3 equals to 29.125 over 40. 29.125, that is, your A is 40 as obtained. 40 R raised to power n. Our n is 3 equals to 29.125 as determined above. So then that is why we have equal to 29.125. To make R raised to R the subject of the formula, divide both sides by 40. So you'll be left with R raised to power 3 equals to 29.125 divided by 40. If you divide that by 40, then you have is 0.728125. That is R raised to power 3 equals to this. To get the value of R, you find the cube root of both sides. R will be equals to the cube root because of the 3 at the power. Cube root of is 0.728125. What is the cube root of this? The cube root of this. That will give us 0.8996. The cube root of that is 0.8996. If you multiply that by 100, it will be equals to 89.96, which is approximately equals to 90%. Therefore, the value of R is 90%. That is the learning rate. That is the answer to example 2. So I want to look at the third example, example 3 now. Example 3. The time taken to produce each of the first 4 batches of a new product were as follows. I given the batch number 1, 2, 3, 4. Time taking 100 minutes, 70 minutes, 62 minutes, and 57 minutes. These are the time taken for each of the batch. Based on the above data, calculate the learning curve rate. You want to calculate the learning curve rate. This question is also obtained from ACCA study test by Kaplan. You want to calculate the learning curve rate. You are given the batch number 1 to 4. Solution. Let's have the batch number. Solution. Batch number 1, 2, 3, 4. That is if you want to use the tabular approach. Then you are also given time taken. 100 minutes, 70 minutes, 62 minutes, and 57 minutes. The time taken. You have 100 minutes. The time taken is in minutes. 100, 70. Then we also have 62 and 57. If you look at the first question I solved using tabular approach, the cumulative average time was given, but this one you were only given the time taken, not the cumulative. Therefore, you will need to calculate the cumulative time and the cumulative average time. Cumulative time and the cumulative average time. Cumulative average time. So that it will be in line with the first example. So here you have 100. If you have 100 divided by 1, it will still be 100. 100 plus 70, and that will give us 170. Cumulative, you add each successive unit. 100 plus 70, that will be 170. 170 divided by 2, and that will give us 85. 170 again plus 62, then you have 232. 170 plus 62, you have 232. 232 divided by 3, and that will give us 77.33. 77.33. To get the average, cumulative average time, you divide the cumulative time by the number of units in each batch. Then 232 plus 57, and that will give us 289. 232 plus 57, you have 289. 289 divided by 4. Divided by 4, then you have 72.25. Now, remember, learning curve theory operates on the system of continuous doubling. If you have 1, if you double 1 times 2, that will be 2. That means this can be obtained by doubling. If you have 2 times 2, it will be 4. But 3 cannot be obtained by doubling. You have to strike out this column, the one that cannot be obtained by doubled. So now you'll be left with 1 times 2, that is 2. 2 times 2, that will be 4. Now, remember, you may use the tabular approach, and you may also use the algebraic approach. But if you want to use the tabular approach, you find the percentage decrease in the cumulative average time. In cumulative average time. To calculate the percentage decrease, you have this one will be nil. For this column, you'll be having 100, the first value, minus 85. 100 minus 85 over the first number, which is 100 again, times 100. 100 minus 85, that will give us 15. 15 divided by 100, it will be 0.15. 0.15 times 100, that will be 15%. Percentage decrease is 15%. Since learning curve is operating on a system of continuous doubling, remember we have striked out this. Here also you have 85 minus 72.25 over 85 times 100. 85 minus 17.25. Minus 72.25. 85 minus 72.25. Then you have 12.75. 12.75 divided by 85. Then you have 0.15 times 100. You also have 15%. Percentage decrease is 15%. So our learning curve rate now, that will be 100 minus 15, which is 85%. That is the learning rate using the tabular approach. To use the algebraic approach, method 2. To use the algebraic approach, you have the learning, we have a raised to power n equals to, I've told you that this will be equal to the cumulative average time per unit. Cumulative average time per unit, and that is 72.25. So that means you equate it to 72.25. Our A is the average time of producing the unit in the first batch, and that is the time is also 100. So that means you have our A to be 100, so we have 100 R raised to power n, and we said n is the number of times the activity will be doubled to obtain the cumulative output. Remember, the cumulative output now is 4. So if you double 1, if you double 1 times 2, that will be 2. That is the first time. If you double 1, you have 2. 1 times 2, 2. If you double 2, 2 times 2, 4. That means it will be double 2 times to obtain this 4. So that means our n is 2, equal to 72.25. So you want to make R the subject of the formula. Sorry. Our A is 100. R raised to power n is 2, equals to 72.25. Divide both sides by 100. You have R squared equal to 72.25 divided by 100, which is R squared equals to. Now, divide 72.25 by 100. Then you have 0.7225. So, to find the value of R, find the square root of 0.7225. R will be equal to square root of 0.7225 because of the square. That is why you need to find the square root. So what is the square root of that? The square root is the square root of 0.7225. The square root of 0.7225 is 0.85. R equal to 0.85. You multiply that by 100, R will be 85%. That is the learning rate. So which is also the same with the result obtained under the tabular approach or tabular method. I want to consider another work example. I've told you that the first 3 examples was obtained from Kaplan, ACCA study test, performance management. This fourth example, number 4 example, is obtained from workout performance management by Omolehinwa. Workout performance management by Omolehinwa. So the question, Lab Limited has started production, the production of a new product. The management accountant has recorded the following output and the related labor hours. Total time for the first 800 units, and that is 56,000 hours. The second one, we have total time for the next 800 units, and that is 44,800 hours. We are also given total time for the next 1,600 units, and that is 80,640 hours. Then the management accountant is now planning for the first quarter of the current year, which is January to March. It is estimated that production in each of the month will be, we are given January 3,200 units, February 6,400 units, March 12,800 units required. A. Determine the learning rate. B. Calculate the total labor hours needed for each of the 3 months of January to March. That is the question. You are not given the learning rate and you want to determine the learning rate. Solution. Now let's have the solution to the question. Solution. We will also use the 2 methods. Let me start with the tabular approach. You are given the units or output. The output is given. and the time taken for each of the output is equally given. The first units you are given, the output were given. Total time for the first 800 units is given, total time for the next 800 units, and total time for the next 1,600. We have 800, 800, 1,600. So you have 800, 800, and 1,600. Then, if you look at the examples I've solved so far on the use of the tabular approach, I calculated the percentage decrease in average time of the cumulative output, or the cumulative average time. The percentage decrease in the cumulative average time. That means to get the cumulative average time, it will be cumulative time divided by the cumulative output. On the basis of that, you will need to calculate the cumulative output or cumulative units. Cumulative output or units. The first one is 800. The cumulative 800 plus 800. That will be 1,600. 1,600 plus 1,600. You will have 3,200. Then, the time you are given. For the first output, you are given 56,000. The second one, 44,800. And the third one is 80,640. So the time is, let's have the time. The first one is 56,000 hours. The time is in hours. The second one is 44,800. And the third one is 80,640. Then you need to calculate the cumulative time. Cumulative time. So the first one, 56,000, which is also in hours. The second one, 56,000 plus 44,800. That will be 100,800. 100,800. The third one will be 100,800 plus 80,640 plus 80,640. Then you have 181,440. This is the cumulative time. And what we need is the cumulative average time, not the cumulative time. We need cumulative average time. Now, let's include the cumulative average time now. Cumulative average time. So the first one, when you find the average, 56,000 divided by the cumulative output. 56,000 divided by 800. Then you have 70 naira. The cumulative output, the first one is 70. The second one, 100,800 divided by cumulative output of 1,600. 100,800 divided by 1,600. There you have 63. The third one will be 181,440 divided by 3,200. That will be 56.7. 56.7. So The next thing is to calculate the percentage decrease in that. What will be the percentage decrease in cumulative output, in cumulative average time? Percentage decrease in cumulative average time. So that means you have, this one will be ni. The second one will be 70 minus 63 over 70 times 100. So this will give us 70 minus 63. 70 minus 63, that gives us 7. 7 divided by 70, that will give us 0.1 times 100. Then you have 10%. Then the next one, 63 minus 56.7 over 63 times 100. So this will also give us 63 minus 56.7. Then you have 6.3. 6.3 divided by 63. Then you have 0.1 times 100. So that is 10%. So the percentage decrease in cumulative average time is 10%. Therefore, our learning rate now, learning rate will be 100 minus 10, which is 90%. That is with the use of the tabular approach. But if you want to use the algebraic method, we have the formula to be AR raised to power n equals to, what is the cumulative average time? The cumulative average time as determined is 56.7. So that means we equate that to 56.7. And what is the value of A? A is the time for the first unit, or average time for the first unit, which is 70. So that means we have 70 R raised to power n. How many times will the activity be doubled to obtain this cumulative output? Remember, the cumulative output is 3,200. If the first activity is 800, if you double it for the first time, double 800, you have 16. That is the first time. If you double 16, you have 32. That means it will be doubled 2 times to get the cumulative output. So then that means if it will be doubled 2 times, our n is 2, equal to 56.7. So make R the subject of the formula. We have R squared equal to 56.7 over 70, which is R squared equal to, if you have 56.7 divided by 70, then you have 0.81. 56 0.81. So to find R, we find the square root of both sides. The square root of 0.81, our R will be, what is the square root of 0.81? That will give us 0.9. If you multiply 0.9 by 100, our R will be 90%, which is the learning rate. So whichever method you use, it will lead to the same result. Now that is for that. Then B aspect of the question. Calculate the total labor hours needed for each of the 3 months of January to March. Aspect of the question. B aspect of the question. You have to calculate the total labor hours needed for each of the 3 months, that is January to December. You have been given the units. The first unit is 800 units. The second unit is also 800 units. The third unit is 1,600. Then for January, you are given 3,200. February, 6,400. March, 12,800. Remember these hours, which have been used to calculate the cumulative hours: 56,000, 44,800, and 86,40. Take note of that. It will be used. So January 3,200, February 6,400, and March 12,800. Then cumulative time. Cumulative time, you have 56,100, 800, and 181, 440. Cumulative time. Cumulative time. You have 56,000. Then we have 100, 800. We also have 181, 440. Then we have cumulative average time. For the first output we have 70. The second one we have 63. And the third one we have 56.7. Sorry, there is a rain here, and that rain might affect the quality of the video. I'm trying to complete the question. So then for this, since the learning rate has been determined to be 90%, for this level you have 56.7. What is the 90% of that? The 90% of 56.7, that gives us 51.03. 51.03. Then the 90% of 51.03. The 90% of 51.03, and that is 45.93. 45.93, that is for February. Then the March, 90% of 45.93. That will also give us 41.33. 41.33. Now, remember, the time for January, February, and March is equally given in the question. Okay, it's not given. The time for January, February, and March is not given. So to supply that now, remember the average time which was obtained. The average time was obtained. This average was obtained by dividing the total time by the number of units of output. That means to get the total time now, you just cross multiply. Your total time will be the average time times units of output. So now, if you now have 3,200 times 51.03, 3,200 times 51.03, then you have 163,296. 163,296. 163. Sorry, I didn't calculate the cumulative output. I need the cumulative because I was rushing. The cumulative units needs to be calculated. So I ought to multiply this by the cumulative units. I don't know if I can manage this place because of the rain. I'm trying to rush the whole thing because of the rain. So let me rub up this. The cumulative units. We have 800 plus 800, 1,600 plus 16, that is 32. 32 plus 32, that is 64. 64 plus 64, that is 12. 8. 12 8. 12 8 plus 12 8, that is 25,600. This has been determined. And this one let me just put the total time here. Total time. Sorry, the quality of the video has been affected by the rain. The total time for the first 800 has been given to be 56,000 hours. For the second, the cumulative total time as calculated, the cumulative from our first working, that is, we have 100, 800, and the third one is 181, 440. 100, 800, and 181, 440 from our first working. So now let's just insert that. So we have 100, 800, then we also have 181, 440. Then to get for January, you have 6,400, which is the cumulative output in January. 6,400 times 51.03. 6,400 times 51.03. Then you have 326,592. Then we have 12,800 times 45.93. 12,800 times 45.93. 45.93. Then we have 587,904. And the last one, we have 25,600. 25,600 times 41.33. Then you have 1,058,048. These are the results required for January to March. January to March. That is the end of the solution to the question. Should be expecting the part 2 as the continuity to this. Thanks.